Hey everybody, so I wanted to show off this demo of kind of the project I've been working on for like, I want to say the last week or so. So for those who are not familiar, we used to have a tool, and we kind of still do, for kind of doing mathematics and stuff for ICBM. So like when we're doing a lot of the stuff in terms of calculations, we're not sure if this will work or how it'll function or like is it going to do what we're going to expect to do. And rather than sitting in a game and kind of like testing over and over and over again to see if it kind of looks right and kind of guesstimating that, or doing a lot of like data entry and then running some automated tests and trying to do that stuff, we built this tool. More specifically, I built this tool and kind of got some help from a few others to make sure the math was just kind of correct. Created it to kind of be able to do a lot of that stuff, be able to do like accuracy checks, to be able to check to see my ray tracing, my blast, my pathing. And I've shown this off in the past, and I think some of the parts I've shown off and kind of how this sort of works. Because this is the old tool we're looking at, is I've showed probably off like how we do the calculations for the missile paths, getting that parabolic ballistic path going on. It's kind of realistic, not quite. I really want to rework this and kind of handle it more, but I can do different kind of paths, set up different kind of variables, do that kind of stuff. I come over here and check, okay, what's my accuracy fall off going to look like? So, that randomization, is more of my stuff going to hit towards the center rather than towards the edge? Am I going to still get that fall off? So that way, if I am shooting further away, I get the same ideal as if you were firing a missile in real life, and you would have that wind being pushing it off, or maybe a slight miscalculation in the circuitry would end up with that inaccuracy, or maybe the missile vibrate a little bit on its stand and cause it to just launch a little bit incorrectly, would be what accuracy. But the part that I really want to work on, and this tool has kind of been starting to fall on the weak side because this is built in Java Swing. So it's a really old, like kind of legacy way of building UIs. And the whole reason I kind of built it this way was just, this is something I knew at the time. I knew this would work, and I didn't have to sit there and learn a whole bunch of new techniques or methodologies in order to build a tool that would get me something I can play with, and kind of test my theories and ideals and everything else. So for that, I can run calculations here. And for example, this is our blast large, which is what I believe the nuke, and for a while the antimatter used to use this calculation. It's pretty much just a better version of the TNT blast. It uses angular math to figure out where the ray traces need to go. It passed relatively well. It kind of, for the most part, can scale up and down decently okay. So if at 10, we're pretty good. But like I say, if I match, say, TNT has a size of 4. So if I calculate that, we get a relatively decent algorithm with very little wastage in terms of how often we're hitting it. So the heat map in the background is kind of showing me how many times I'm hitting each block. You want to hit the block as few times as possible, because the more times you're hitting it, that's the more time you're checking into the world. You're asking the world, okay, what block is here? What is my explosive resistance? You're running the math for that. And then you're usually popping edits back off either into the world or into some kind of queue. Minecraft's code just flat out just sets the block over and over again. More specifically, it pops it into a set and just kind of holds onto it, but it's still not good. So we have a better algorithm for that. We don't really use it for the smaller scale because the condensed TNT and ICBM is quite literally the TNT blast, and its reason is so that they behave almost identically to each other, rather than having something that's much more unique. But for say things like nukes and stuff, like which has a blast radius of 60, and this does take a while to run, which is one of the other reasons, and it's not very usable when we're trying to test, okay, what is this actually doing? So I have to expand it. I'm sitting here staring at it. I have no real zoom ability, and I could bake zooming into this code and everything else, but it's not super functional, and it's really, really hard to test at those larger sizes. Now I can do things like turning the dots and lines off. I can rerun that calculation, which will take a little bit to run, and I can get something like this, which gives me a little bit better understanding of like what my code's doing. And I can tell that the center of my algorithm here is terrible in terms of performance, but then the outside, it's okay. It's doing relatively okay and giving me pretty much what I really want to look for, because the center like may look terrible, but there's more volume out here on the edge of the calculations in terms of what they're trying to function as, how many times we're pathing, how many times we're accessing the world. And you got to keep in mind, like, this is a radius of 60, I think. So that's actually, I think it's actually lower. I think 30 would be the radius, would be the nuke would be in terms of things. I actually could just check the code and figure out what it actually is. But like, yeah, so this would be in terms of like volume. So you have like 60 times, like, I believe it's, I actually don't remember the algorithm for volume, but I know it's like a decent amount. You end up with a huge amount of space and number of blocks you're processing. I know it ends up being like somewhere close to like 500,000 blocks. But we have different algorithms here, which unfortunately, due to some of the limitations of Swing and me just not wanting to go in and fix this, it's a little hard to figure out what I'm selecting. So here's TNT. So if we go back down to that 4 size and calculate it, it's not great. So like you saw the difference already between, just doing blast large F4, which does this, versus TNT, which does this, which is hold on, let me select the right thing real quick and make sure I normalize vectors. And you end up with like this kind of algorithm. And then we have different ones. Like we have like ray circle, which is much better in terms of efficiency. Edge cubes, which is, it's decently well. Like I think ray circle doesn't actually work the way I think it does. Edge walls, which is just actually doesn't show me ray trace at all. That just shows me the algorithm for calculating edges. I think this is the actual one that does the ray tracing. But you can see like different algorithms do different things and give me different things. I also have stuff in here for like calculating red matter radius and stuff. I have a math for our gas clouds. So when you're doing like different things like that, this is courtesy actually of GHXX. So that he's the one who actually spent a lot of time working on this in terms of like the code, and I just replicated it inside of the tool so I can kind of like see what we're doing and kind of like see kind of what's happening, like how are our particle density working out, how many runs am I doing here, which usually you actually just run one run. And like, actually, no, you wouldn't run one run because I think one run is only like one expansion. But it would tell me how this would look after like X number of expansions and like how the algorithm would function and different things, which is really cool. So like you kind of seen this old tool, it works. It gets me kind of what I'm aiming for. Gives me a whole bunch of data over here, really useful for figuring out what's going on. But maintaining Swing is a bit tedious and honestly not that enjoyable. I used to love it just because working with Java code is absolutely phenomenal, and it's like really fun to kind of write all that Java code. But at the same time, like just because like Minecraft is also Java doesn't mean it contributes well to building these UI elements. And it takes a lot of effort to build them and a lot of like code. And I can even show what some of that code even looks like, because it is not exactly pretty. And it could be optimized more. That much I can tell you. But like here's like one of the calculator panels where we're having like to manually add panels and layouts and do J panels, and like there's a lot of code here just to do the layouts. And this is something that isn't all that great. And we could flip over to Java FX, which would give us a little bit better layout, but it would be pretty much doing our UI layouts in XML and then writing our code in Java, which would give us something a little bit less worse than what we have here, but would still have similar problems in terms of building layout, but it would be a little bit easier. But I was like, you know what, if we're going to spend the time to do XML-based stuff, I can instead go through the effort to actually just build a new UI and build this as a web tool. So the advantage of building this web tool is, one, I'm working with stuff that's built specifically for the purpose of displaying content. Websites are amazing at it. They may not be the most performant things in the world, but they are built for displaying information, letting users navigate. They're very responsive. So I can take this browser window, I can change its size, I can resize it, I can get scroll bars, I can do all that kind of stuff, and I don't have to think too hard about implementing it. I can also take advantage of a lot of the more modern frameworks. In this case, this application is built in React, which means I don't have to work hard to build simple components. And it's something I'm also really familiar with since I've spent like 4 years doing React for a large retail company. So not only did I, do that code, I helped that company kind of adopt that technology. So a decent amount of experience with it. But it gives me a lot more flexibility. My code can be separated into the logical blocks, which can be the JavaScript. In this case, I'm actually using TypeScript. Similar concept, just has typing. And then my HTML is kind of just built out into its own little components where they're kind of separated out and everything else, which I say separated, and I've kind of got my stuff mixed all around. You can look at the code. It's not much better, and that's just because I've been lazy this last few days and not wanting to kind of separate this all out. But in terms of features, I've finally got this to the point where it works the way I sort of want it. Visually, I'm going to have to work on it. I want to get a kind of a dark theme in here. I want to get something very similar to the Dracula theme that you see inside IntelliJ and WebStorm. They're much easier on the eyes than just a pure white UI, which I got halfway into, had it looking well, and then I decided, okay, I want to really work on components and kind of fast track the components, and then I just was like, I don't want to mess with the styling anymore. So I got things to a point where they work, but don't necessarily look good and may not be the best user experience possible. Like I need to move reset buttons around. I need to change how run button works. I don't have to come up here and click reset. But beyond that, like I have the ability to zoom in and out on this. I have the ability to create map systems. So let me, if I reset this all the way out, so you can see this, I can add modifiers. Let me turn the grid back on and let me turn the tiles back on. So I can come in and say, okay, I want to throw pretty much say like a cobblestone block, which as soon as I go to mess with this, it breaks. It was working perfectly fine. Um, I know what probably happened with that, and I can fix it in a couple seconds, and y'all get to see some live like diagnosis of issues. So I did a refactor not long ago where I changed the word tiles to map, and I think WebStorm got confused and renamed it in multiple spots. So in terms of how this laid out, we have like a map page, and it has basically a total outer layer, but then I have a whole bunch of stuff that honestly needs to be moved to subcomponents. For those of you who are kind of familiar with like React and everything else, this is not how you would do things. You would break this into a component, and then this whole section would also be a component, and so on. So you keep componentizing things so you can keep like separation of concerns, get your stuff isolated, and then you don't have to worry about it. But in terms of I'm lazy and have been writing Angular way too much for the last year and a half, I've gotten into some really bad habits, and this is the results of that. But I need to do a really quick check, because what ends up happening is I went to go set a tile, which is probably handled in one of the modifiers down here. Because all I do behind a modifier is it's basically just a way of saying I want to do something to the map. And right now I've kind of have it set up as like tile modifiers, but the idea would be more conditions. You might be like adding entities to the world. You might be running multiple tests. I think I'm going to merge the simulations up into the modifiers at some point, just because there's no reason they should be separated. Apply modifier, set modifier. Let's generate maps. Let me really quickly check where that code is failing at. That would have made my life easier. Of course it's bundled. Set tile ID is what's happening. Sometimes React is just, it used to be much better about like error diagnosis, and then recently it's just not been that great. I don't know when that changed. Like I've been out of the picture for like too long to even remember like when things have changed or when things are not working the way I want them to work. But there's build modifier. Modifiers. This is my modifier, which is box modifier. Ah, there it is. Yeah, so that's kind of what happens. React decided to rename, or not React, WebStorm decided to rename things that didn't actually need renamed because it couldn't tell the difference. And I think it's really just a lack of proper support for things like JavaScript and TypeScript, even though it is a IDE built for that. I don't think they put a lot of their focus in that. I think they put a lot of their focus in some of their other tools. But I don't know for sure. But yeah, let me try this again, because that should have just immediately reworked. One thing I really do like about React that I haven't got it with Angular and a couple of the frameworks, this just actively just reloads with all my stuff still in it. Like I don't lose my data, which is really cool. But yes, I have that, and I click generate. At least it should have generated. Let me add another tile in here. Just make this a 0.5. So I haven't been testing with the generator options. So lo and behold, they've probably been breaking. Automation testing is like why you do this kind of stuff. Receive NaN for value attribute. This is expected. That's always fun. Okay, so I can't really show that feature, but the idea would be is like when you click generate, you can generate different objects on here, and one of the purposes behind that would be to set up like tests. So if you want to go, okay, how is this explosive going to behave in regards to say a mountain right here, or somebody has a cave entrance, or somebody built a bunker, or so on, which is really really useful in my case, because one of the things I want to eventually do with this tool is start writing better algorithms for how our blast code works, because right now our blast code works entirely off of ray traces in a lot of cases. And ray traces are really cool. They work. They will tell me kind of what the center of the blast can kind of see going outwards, but they don't behave like actual blasts do. Actual blasts have pressure waves. So if like a pressure waves of a fireball, they'll have like shrapnel and stuff like that. So shrapnel can easily be done via ray traces, and is very easy to predict that way. Or you throw some entities or particles and make them do your work. But then it's the fireball and the pressure wave are going to move like a fluid. Specifically, they are fluids. So like a pressure wave is going to be fluid being pushed at a high velocity from the center of that blast outward, and it's going to kind of impact with force onto things. And it's not just going to kind of stop. It's going to push around objects. It's going to wrap around objects. It's going to go through, containers and holes and doorways. So you could have a blast go off outside of a doorway, and the pressure would push through a doorway, and it could still do concussive impact to anything inside of that, like past that doorway, which right now the current code can't do. It'll hit that doorway. It'll go through the doorway as far as it can see line of sight, like a beam of light from a flashlight. But then if you're like on the right around the corner of the doorway, you wouldn't take any damage as a player, which is actually somewhat problematic when you're dealing with a bigger blast. It means you can survive just by hiding behind like a couple lines of concrete, which I still want it to somewhat offer protection, but I want the protection to kind of like scale relative to what's going on, around you. So like if you are enough of a distance away from something, it would work. But that's getting into too much details and too much nuance, and we can talk about that in another video. First, I can show off what parts I do know still actually run in this tool, because I've been using it pretty much nonstop to test TNT, which seems a little bit weird because there's no point for me to really be testing TNT. But it kind of gives me some idea of like what the application can do, what options I can work with, and things I still need to function. So for start part, once you get this application, you kind of saw it would load like a 2x2 in terms of chunks. So I got this set up to do about 16 by 16 on a grid. Each one of these little squares is a meter, so it's about a block pretty much. You have a zoom functionality, you have the ability to turn things on and off. Of course, you have the generator option over here, which we saw doesn't really work right now, so I have to work with it. And then we have the actual simulations down here. So the simulations I kind of was originally thinking of as running like one simulation at a time. This is where I was talking about I might merge it up with my generators because it's like I want to be able to run more than one just for like edge cases. And I think cluster bombs would be the perfect example of like where you might want to run more. But yeah, we have a drop down of what test you can run. So right now I have the 112 version of Minecraft TNT. I am specifying versions just because the math does change a little bit between versions. And I believe one of the newer versions, the logic itself got rewritten too. So I'll be adding different versions here for comparison. I might be adding some other mods in here down the road too to kind of compare how their algorithms work in relation to our algorithms. That'll be more of just my own curiosity rather than trying to prove any point or anything. I honestly don't care how the people write their code. And for the most part, most of them are just TNT scaled up. But right now I have like two algorithms here. I have like random fill, which just, fills the map with random junk. It's cool, it's fun, it gives me a way to test the application. But anyways, we have a reset button up here that shows up here, but for TNT, this is going to default to trying to place this somewhere in the center of a single chunk. So you have your X, you have your Y. You have the ability to mess with rays. Now, when it comes to vanilla TNT, for those that like especially modders or like content creators, the only two things you actually have available, or three things, you have X, Y, and size. So you can adjust the position, which will be X, Y, Z actually is what you'd be doing. And then you have your size. All these other values are normally not exposed in Mojang's code. The reason I kind of have them all exposed is I'm trying to understand how that logic works, the different flaws, the different weirdnesses, the things you can do with it and play around with it to see if there's like anything I can learn from their code that might be fun to apply somewhere else. It's not the most practical, but there's cool little silly things you can do with their code that is kind of fun to do. But leaving out default values, I can run this, and what it'll do is it'll create pretty much a random blast pattern. It will try to calculate based on what tiles are. If the generator was working, I could show you like how it would punch out, stone or dirt or something else and kind of show like how the hole would work simulation wise. Most of the time for those familiar with, stone, you would punch out pretty much a 3x3. Dirt's going to be like a 5x5 or so. So it gets a lot of different energy thing. By default, Mojang's code is going to randomize the energy. So if I turn off, say, for example, this right here, which is randomized rate energy, I can click reset, I can click run, and you'll get a more perfect circle. So Mojang's code tries to randomize it, tries to give you this kind of unpredictability to the larger sizes of it, and it makes for a funner experience, because if you get a perfect circle every time, it looks kind of terrible. We ran into this in past experiences working on the antimatter explosive, where we removed feathering for a while, and it created this too perfect a circle, and then we added feathering back, which just kind of randomized the maximum distance that the antimatter could travel per axis, which allowed it to create these little holes in the wall, which looks okay, but is not as nice as the randomization here is. And this randomization kind of works based off energy, and it's one of those cool little fun things that you can play with, and we can take over into our other algorithms and be like, hey, let's just randomize how much energy we get per path, or how many should we lose per thing. Some other values I can mess with in here is if I'm like turning off normalization, I actually can force this to go into a box mode. So I can click run, and now it's a square. Another little fun trick we can play around with the TNT. I can change, how many steps we do. So steps doesn't really do anything kind of cool per se, but what it does, if I can kind of zoom in and kind of show and explain what's going on here. So one, the zooming is kind of really fun in terms of like trying to see what's going on. But we have these arrows in here. So originally in the old version, we were just drawing lines with some dots. The arrows kind of show me the vector, and for something like TNT, that's not particularly useful. It's going to become more useful with other algorithms that may not be moving in a straight line. So they may be diverging off at 90 degrees or 45 degrees. They may be pathing differently. And so it'll show me that what's going on. But in here, I can use the arrows. And I can also reference the size of the arrows. The arrows will change size along with the lines to indicate how much energy is left in that ray. So the code knows exactly how much energy is, and this is something I kind of maybe want to do here later on, is actually start to draw the numbers here when you zoom in enough, so you can kind of see like, okay, how much energy did I start with? So how the energy algorithm kind of works in Mojang's code is it starts off with the size. So size is also your energy level, which may be a misnomer in terms of how their code works. Because when we work on the modding side, we're kind of decompiling and we're working with namings that may not be what Mojang actually uses. So it may be called size in our naming remappings, but in Mojang's code, it may be called energy, or it may be called scale, or it may be called power, or some other value. But theirs starts off as 4. And then they kind of scale it down by 0.7, and then they scale up again by like 0.6 by random. So you can have anywhere from like 70% to let's see, 130% of your actual energy, starting off with each ray. And the ray will go out, and each time it goes out, it's going to lose 0.225 energy wise. And that's per step. So step sizes are 0.3. So you can scale these up in order to kind of not have to path as much. And honestly, you can actually mess with this algorithm and take this to 0.5 right away. And if I click reset and run again, you'll notice I still get relatively the same style of blast while pathing less. So for those who want to add performance improvements to just Mojang's code by default, you can just mess with simple values like this. Of course, getting that into the actual code is a little bit more difficult because the way we have this implemented, or at least I have this implemented in terms of the TNT blast code, is I have mimicked their stuff in terms of code here. So this code internally from like these for loops and so on is a simulacrum of what their code does. I've modified things. For example, I've allowed myself to turn off the normalization. I've renamed some variables to make it more readable. I've changed all kind of stuff. So if I actually go and we find my actual ICBM project, I can actually show you what TNT's code normally looks like, so you can kind of see that comparison. So in Mojang's code, at least the way we have it renamed for Forge, it's called Explosion because it's very generic. It works for the TNT, it works for the mine cards. I believe it also works for fireballs and wither heads and all that other stuff. So it's used for a variety of things. When it's created, you pretty much set the position, whatever entity caused the explosion, like world position size. You can set flaming, you can turn damage train on or off. But the actual explosion logic is going to work with 3 different loops on a 16. It's going to only take the edges because it's kind of basically an edge pather. So it's a very large inefficiency right here. Although it doesn't matter nearly as much because like as long as the code inside this if statement doesn't run, it's basically 1 nanosecond to path each of these 4 loops. So it's very, very slow. But you can see a lot of this stuff isn't named well, but we get our vector creation here. We then normalize the vector. So instead of it being a box, it turns into kind of a circle shape. We then calculate our randomization for energy. We then get our starting position, and then we just kind of path through. And you can kind of see there's some artifacts from the decompilation process. This value and these values down here are probably the same values, at least in terms of this 0.3. And I suspect Some of this is also meant to be a similar-ish value. Like I think this is meant to be the same as a step, and this is just some minimum value that it does. And you can kind of see that set for the block posit they use, but it does create a lot of memory waste and everything else. So they'll hold on to that. They'll also then do pathing to do damage entities. And then after they figured everything out and fired off all the appropriate events and everything else, they'll actually do the proper block destruction over here, and they'll spawn particles and make it look pretty, and you get your block drops and fire and tons of other things. So you can see the code's like not the best to read. It's not easy to figure out what's going on and understand what's happening. So when we flip it over to this side, we rewrite it, make it easier to wrap it back into custom functions and stuff, handle a bit different, and then I'm able to track, what's going on with my simulation. So I'm able to track the positional, and this is like tile position. What edit is this in my entry tree? What editing am I doing? Am I replacing with error? Information about the source, where my path starts and ends, how much energy each of those paths do, and so on. And I plan to expand this like more and more as I go, so that way I can track better information and be able to understand more and more like what's happening. I might track, how long did this actually take to run? How many loops did it, take to get through certain points? Like how often did we access the world during this? So for example, like this would be a single world access, and this would be a single value access off of the blocks. You could calculate those and add those up and go like, hey, we ran this blast and we accessed the world like 5,000 times. And that would be a good comparison to determine which of two algorithms are actually better, because algorithms can be apparently slower, look like they're actually slower. For example, we may, path a lot here, but if we're not actually accessing the world or doing anything, we're just kind of doing some basic math, and CPUs are really good at doing math, so it's almost ignorable. But doing things like world accesses are a little bit slower because you have to kind of dig through multiple layers of checks. Like, is the world loaded? Is the chunk loaded? Maybe you have to wait on the chunk to load. We have to do like an asynchronous check to make sure this is working. Oh, we have to do this. And so a lot of things that kind of go on, especially in newer versions of Minecraft. That process gets slower and slower. So your block accesses are actually incredibly slow. And that's something we can track performance-wise here. But kind of moving on in terms of other things, you can pretty much mess with all these different values. You can do series of min energies, scaling energies, normalize it. And the ideal would be like every blast we add to this, or every algorithm, because it will be more than just this here. We might be doing radiation math in here. We might be doing reactor heat spread in here. We might be doing like all kinds of different things in here. And of course, I'm going to clean up the UI. You're not going to have this like mess here. I'm probably going to have some tabs down here and some better boxes to organize it. But you'll be able to mess with all kinds of stuff in here and do this. And other cool things you can do with this is you can actually click save as, and you can actually save these images. So if you want to like show these off to like friends and kind of understand like what's going on here, or put these in a wiki, or demonstrate different problems that different algorithms might have, you can mess with the heart's content. And this is the reason why you can do things like turn the grids off, you can turn the lines off, and you can sit here and look at this and look at different behaviors. And maybe you just want to look at just the lines. So there's a lot of like messing with this. Given it's mostly for me and my team to utilize, but I have actually pushed this out. And it is sitting on GitHub, and it is accessible. So if you go to GitHub Dark Guardsman, which I badly need to rename my account, I can go to the ICBM calculator web, and I don't have the link in here. I actually need to put the link in there, but I can grab the link out of the package JSON. And I have this set up to auto build and deploy. Now, as you can tell from this commit, it failed to build, but I'll have to go figure out why that is. Maybe because I exceeded my capacity for the day. But I can actually jump to this version, and here's a live version I can actually run. I can run it all the same, and this is an older version. So I got to figure out why this didn't build, and it's probably like something really dumb. Yeah, it's ESLint issues. For those of you who like mess with React and you set up base projects, CI tools like to die on ESLint because the defaults pretty much don't want to let you have errors. So you can have errors or warnings in your locals, and you can compile and test your heart's content, but as soon as you go to build it and publish it to a production environment, it's set to not allow those. This is something I'll probably come back in and I'll disable it, but it's just a whole bunch of like define checks and it failing me. But that's it for the moment. You all can jump and mess with this and have fun to your heart's content, and I'll be back hopefully in the future showing off more of this, as well as some of the impacts to the mod itself and how that would improve, with probably the first target going to be like probably the EMP.